All right, guys, here we go with the first section of Chapter 2, Relations and Functions and Representing Them. Let's go. Hopefully you've seen some of this before in Algebra 1 and remember some. If not, we'll review it anyway. It says, consider the relation given by the ordered pairs, -2, -3, -1, 1. You can read them all the way to 3, 1. First of all, when you ever see this word right here, the word relation, means any set of ordered pairs. So any set of ordered pairs is a relation. Any graph is a relation. Part A says identify the domain and range. I got a great gesture for you tomorrow for domain and range. I know you're looking forward to that. But the domain are the possible x values. So the domain would be all the x's, -2, -1, 1, 2, and 3. So domain are the x values. The range are the y values. Range is y. Domain is x. So the range is -3, 1, 3, -2, and 1. Part B says represent the relation using a graph. So all I did is I took those ordered pairs and put them on a graph. I'll talk to 1 or 2 with you. I don't think you know how to graph. -2, -3. I went left -2, down 3 to that one. The second point was -1, 1. So went -1, up 1, went to there. And the last thing I said, mapping. So whenever you do a mapping diagram, you put all your x's in one column, all your y's in the other column, and you just match them up, -2 to -3. You just map where they go, what x goes with which y, and draw an arrow there. That's called mapping or a mapping diagram. This one says tell whether the relation is a function. Here's how you can tell. A function is when every x has exactly being the key word, exactly 1 y. That's a function. Every x has exactly 1 y. So that means everything in the input should go to exactly one place in the output. If I'm looking at this one, if you look at the input, that all has one arrow from each x, so it means every x is going to 1 y. That is a function. That's a yes. If I look at this one, look what's happening with the 1 right here. That one input, or x, is going to 2 outputs, or y, so that would be a no, because one of the inputs has 2 different outputs. It's only a function if every x has 1 y, or every input has exactly 1 output. Vertical line test is another way that you can tell if it's a function or not. If you see a graph, I want to know if the graph is a function. If you draw a vertical line through this one, no matter where I draw the vertical line, I just touch the graph. That's a parabola just one time. That would be yes, that's a function. If I can draw a vertical line like that red one or this green one, and I hit the graph more than one time, that means it's not a function. No, and the reason is because, like, if I hit it, let's say what the red line is. If it touches there and there, that's the same x. That point is 2, 2, and 2, -2. So that one x has 2 different y's. That's why the graph works. Vertical line test works. A couple words here. Y equals 3x minus 5 is called an equation of 2 variables because it has 2 variables. It has an x and a y. X is called the independent variable, meaning you can put anything in for x there you want to. But y is called the dependent variable because the value of y is completely dependent on what you put in for x. So y depends on the value of x. So that's why it's called the dependent variable, and x being the end, because x is whatever you want it to be. Okay, it says graph the equation y equals -2x minus 1. We're going to start off by graphing by just making a table of values with these values for the x. So I'm going to take the -2. I'm going to take this -2 first, and I'm plugging it in. For that x, it would look like this: -2 times -2 minus 1. If you work that out, you get 3. Now I'm going to do the same thing with -1. Put it right there. It would be -2 times -1 minus 1. That would be 2 minus 1, which is 1. Plug in the 0. -2 times 0 minus 1. That would be -1. And plug in the 1. -2 times 1 minus 1. That'd be -3. And then plug in the 2. -2 times 2 minus 1. And that would be -5. All right, now if you notice there's a pattern in the y's. Anytime we're graphing a line or a linear equation, if you put in numbers for x and they're in a pattern, your y's will also be in a pattern. That's a freebie. Free piece of information for you. So I'm going to graph of negative 2, 3, negative 2, 3, right there. Negative 1, 1, about right there. 0, negative 1, about here. 1, negative 3, down here. And then 2, negative 5, which is, sorry for my graph's not very accurate. Should be a line. I'm pretty close. Should be a straight line there. Graph the equation. You can connect the dots. La, la, la. Oh, you don't know what that means. And it should be linear. Should be a line. Oh, here we are. Linear function. Linear function, if you have in your equation or function, you have no exponent greater than 1, because if you do, it's no longer a line. And the graph is a line. That's why it's called linear function. Function notation, by the way, is this symbol right here. That means f. It's the way you read that, and you know this already. That is called f of x. If you see it this way, you would say g of x. And all it is, all I want you to think about when you see f of x or g of x, it's just a different notation for y. It's another way of writing y. That's all it is. Don't let it confuse you. Like this. Instead of having an x-axis and a y-axis, you can have an x-axis, sorry about that, and an f of x-axis. My voice, oh my gosh. F of x-axis. Okay, one more slide. Tell whether it's linear or not. Okay, I've already given you a hint on this first one. If I'm looking at that one, f of x is negative x squared minus 2x plus sorry, plus 7. Because it's got the square, it's not. Remember, linear can only have exponents as big as 1, no bigger. This one, g of x is 5x plus 8. That looks great. That's really the same thing as y equals 5x plus 8. Remember, that's a yes. It would pass the vertical line test. It's linear, all that good stuff. It's linear, though, because it has no exponents bigger than 1, and it has an x and a y. So it's all good. All right. That's all we got for today. See you in class tomorrow. Look forward to it. We'll go over this as much as we need to, and we'll get it down really good. So see you then. Bye.